Thank you for pausing the video. Very quickly, I'll just work through these problems. Distributing the 3 to everything inside, I end at negative 8 x to the 6th y cubed. On this one, I have to be careful. I'm going to use order of operations. I get to start here because we have something raised to an exponent, so I will just copy this one over. I cannot do anything with that. Distribute the 3, being very careful, negative 27 x to the 9th y cubed. Take my coefficients, I multiply those together, and I get, I have no idea. I need a calculator. 108, I think. 27 times 4, 108. Negative 108 x to the 10th, y to the 5th. Now we're going to divide. Remember, you treat coefficients as numbers you've been working with for a long time. So I would have negative 3. 9 minus 3 is 6, so x to the 6th. 10 minus 7 is y cubed. We are moving on to negative exponents. We are referring to the negative sign in front of the exponent. Negative exponents take the reciprocal. And the key to remember, only if the exponent is negative will you do that. If the base is negative, you do not do that. If there's a coefficient, you do not do that. Now I am going to move on to this one. So when I look at this, how do I write this as a fraction? I would write it over 1. Because this is negative, I have to take the reciprocal. Once I take the reciprocal, I end with x over 4. When you take the reciprocal, the negative is gone. The action of flipping gets rid of the negative. So I start with y to the negative 2. To write that as a fraction so I can take the reciprocal, I put it over 1. Then I take that and I end up with 1 over y squared. Just like in the past, you cannot combine these. The bases are different. These are all over 1. So to get rid of the negative 2, I have to take the reciprocal, moving the x to the denominator. To get rid of the negative 3, I have to take the reciprocal, moving it from numerator to denominator. In order to create a fraction, I would put the 1 on the top. In our next example, remember, to get rid of a negative exponent, you need to take the reciprocal. So when the negative starts in the numerator, to take the reciprocal, it ends in the denominator. On this one, if it starts in the denominator negative, I would take the reciprocal, meaning it would move to the numerator. This one is currently positive, so I do not take a reciprocal. I just write it there. Ooh, I need to continue to simplify, combine like terms. The bases are the same. If I have 6 x's here and 9 more there, I have a total of 15 x's. Now we're going to do division. Remember, when you're dividing fractions, it's kind of like subtraction in the exponents. Now, none of my bases are the same, so I need to take the reciprocal, moving my x cubed to the denominator. I have a y to the negative third, so I also need to move that to the denominator. My m is positive, so it stays in the denominator, alpha order. Ooh, the n's are negative, so they get to go to the numerator as a reciprocal. Notice on this one, we have bases that are the same. So I will subtract. Be very careful. It is x 4 minus a negative 6, which equals a positive 10. That is positive, so it stays in the numerator. Now on my y's, 5 minus that invisible 1, I get y to the 4th. Oh, I don't have anything in the denominator. I just end up with x to the 10th, y to the 4th. Oh, I have an invisible 1 here. 1 minus 4 equals negative 3. So this would be x to the negative 3. But I want all answers written without a negative exponent, so I have to write that in the denominator. Moving to my y's, I would have y 5 minus 9 equals negative 4. So y to the negative 4 means I would write it in the denominator, placing a 1 in the numerator. Coefficients, divide like normal. 30 divided by 5 is 6. Negative 2 divided by that, it would be negative 2 minus 1. I get negative 3. To get rid of the negative, I have to put it in the denominator. With my k's, I would have 14 minus negative 3, which equals positive 17. Because that is positive, I do not need the reciprocal. It will go to the numerator. On the next page, again, we have coefficients, and here we have coefficients. I would like you to pause the video, try those two a moment by yourself, and then we'll compare answers. Please pause the video. Thank you for pausing. These are the solutions I got for those top two questions. Be very careful, you will never have decimals inside a fraction, so I simply reduced. 4 goes in there 3 times, 4 goes in there 14 times. 2 minus 7 is negative 5. That's negative, went to the denominator. Negative 2 minus negative 4 is positive 2. That would go to the numerator. Same idea here. 4 goes into both. Never have decimals inside a fraction. Negative 6 minus 2 is negative 8. Goes in the denominator. 1 minus 5 is negative 4. 4 goes in the denominator. Okay, so you have a couple of choices on this. This is a big problem. This whole thing is raised to the negative third power. So I have to distribute it to everything, even in the numerator, denominator. Okay, so I'm just going to take my time and kind of show my work as I go. I would have 2 to the negative 3. Power raised to a power we would multiply, so negative 1 times negative 3 is 3. There's that invisible 1. 1 times negative 3 is negative 3. Negative 1 times negative 3 is positive 3. So I distributed to everything in the numerator. Now I will do the same thing in the denominator. And I get 3 to the negative third, a to the negative third, b to the positive 6. Negative times negative is positive. Okay, when I look at my coefficients, their bases are different, so I cannot combine them. This one's in the numerator raised to a negative exponent. It needs to go to the denominator. 2 to the third power is 8. 3 to a negative power, reciprocal will bring it to the numerator. 3 cubed is 27. Working with a's where the bases are the same, 3 minus negative 3 is a positive 6. When I look at the b's, negative 3 minus 6 gets me negative 9, so it goes in the denominator. And then finally, I only have one c, nothing to combine or to simplify. That is where I end up. There are a few ways of doing this a little different. This is just distributing this outside exponent to everything. Inside parentheses, we could do some simplifying first. Bases are not the same, so I'm going to leave 2/3 like that. But here I have a's and there I have an a. So negative 1 minus 1 is negative 2, so that would go in the denominator. 1 minus negative 2 is 3, so I'd have b cubed because that would be positive, and c to the negative first would bring it to the denominator. Now I can distribute that negative 3 to everything, so I still would get 2 to the negative third, b to the negative 9. Distribute to the denominator, 3 to the negative third, a to the negative 6, c to the negative 3. Okay. I will then solve. Bases are different, so 27 over 8. I have to bring a to the numerator because it's negative. I have to bring b to the denominator because it's negative. I have to bring c to the numerator because it was negative. Notice we arrived at the same answer. You may either distribute first or simplify within the parentheses and then distribute. If you do your math correctly, you should get the same answer. Let's pause the video and have you attempt this one, and then I will start it. Please pause the video. Thank you for pausing the video. I am going to distribute first. So I would have 4 to the negative 2, x to the 6th, y to the negative 2, z to the negative 4. All over 5 to the negative 2, x to the negative 2, y to the 4th, z to the negative 2, multiplying as I went. Bases are not the same, so I can't combine those. So I end with 25 over 16. 6 minus negative 2 is a positive 8, so it will go in the numerator. Negative 2 minus 4 is 6, belongs in the denominator. Negative 4 minus negative 2 is negative 2, belongs in the denominator.